the last thing we're going to look at is light and sound. Now, before we can actually get into talking about either of those things, we need to talk about the source of those things. We've talked a lot so far about energy. Remember, we've got energy, and what drives energy is the conservation of energy. And that's that first law of thermodynamics. So, when we have energy, we can transform it into other things, but we can't create it, we can't destroy it, we can only move it around. But that brings up a question. If I've got something like this little marker right here and I drop it, what's happened? Well, I converted gravitational potential energy into kinetic energy. So I lifted it up and I dropped it and it was able to move back down. But when it hits the table, when it hits this whiteboard, why does it just stop there? Where does the energy go? Well, we can actually figure that out pretty easily. It makes a noise. We can hear it hit that. So what is that noise? What is that sound? In fact, if I drop something heavier, we'd be able to feel it in our feet. Well, you wouldn't be able to feel it because this is a video, but I would be able to feel it. If I drop something heavy on my table here, my whole table might vibrate. It might start to move around a little bit. So when we have that energy, when we have it dissipate or leave the system that we're trying to work with, it leaves in a certain way. We call that a wave. When energy moves independently from matter, it moves in a wave. What do I mean by independently from matter? Well, basically, we talked a lot about energy in this past unit, and we spent most of our first semester talking about matter. We talked about chemicals, we talked about elements, real physical things. So that's really kind of how we can break up all of physical science. We can talk about matter, and we can talk about energy. Now, when we talk about matter, we can talk about things like solids, liquids, gases, the different elements, how they react, how they work together. We can talk about things like movement. We can talk about how things roll around. We can talk about machines and physical things that are moving together. Or we can talk about energy. Energy where it's not really the physical thing that's moving, it's this quality, this energy that's moving around. And one of the easiest ways to think about that is in an ocean wave, or just in a lake. It doesn't have to be an ocean. So let's imagine that we're standing on the edge of a lake and we throw a rock into the lake. So we're going to do this in, let's do 3 parts. So I've numbered my page here, my whiteboard. I've got 1, 2, and 3, and we're going to just start with the moment that rock hits. So we've got that stone, and it fell through the water. What happened when it first hit the water? We had a nice still lake on a nice calm day. When that rock hits the water, the first thing that happens is it pushes this bit of water down. Now, when that water gets pushed down, this water gets pushed up. And so the first thing that happens is we get this little divot in the water. If we just froze our moment right here, right after the rock hits that water, we get this tiny little wave. Now let's think about a particle in there. One particle of water, one little molecule, just to kind of show that this is going to be the energy moving, not the mass. One little water molecule might have started here, and when the rock hit it, it got moved down, out, and then it moved up. Okay? So right now that water molecule went from here to here. All right, let's look at the second frame, the second step. This water obviously is going to get pushed back down by this. We've all seen it happen. After the rock goes in, we get that kerplunk, and the water sprays back up. So what's our second part look like? Well, we're going to have a little bit more of a wave, but our second part in the middle, it moves back up. And then these bits will have moved down. They'll have overcompensated, and then they'll have pushed the water next to them up. So we'll get this little small wave here. And so it starts to spread out. Well, where did this water molecule go? Well, it had started initially here and it moved to here. So when this moved, it was right here, and then it would have tried to move back into this opening right here. There was this opening where it could move to, so it moved back into here. And so that one water molecule actually just went in a big circle. It went in a circle to get back to where it initially was. But we've got all this movement down here, you know, down water, not downwind, but down water. So the third frame, we would really see that as being more like this. So this wave is going to move down and kind of push the next bit up. So it's going to have this, and this. Then this one's going to have moved back up. It's going to overcompensate and go up a little bit. But it's all going to get a little smaller. Okay, and then this is our middle bit. This is where our rock is now. It's now down at the bottom of the lake. So this was our middle. This is the middle of our wave. As this rock got dropped into the lake, it moves the water around, and all of these tiny little water molecules just kind of move around in a circle and push each other around. And as they push each other, this energy gets to ride along that motion. So even though all the water molecules are going to kind of follow this motion, so they're all going to kind of just, we're going to have one here that moved around like that. We're going to have one here that when this moved around, it got moved around like that. And then when that moved, it moved around like that, so on and so forth. Just all these little water molecules bumping into each other. And as they bump into each other, they're able to cause that wave to travel along the surface of the water. So when we talk about energy moving, energy always moves in waves.